Okay, hi guys, and welcome to this short little video on logarithms. In this video I'm going to go through basically what a logarithm is and some of the laws of logarithms that we've got. So let's start by defining what a logarithm is. So just a quick Google search brings up a quantity representing the power to which a fixed number, also known as the base, must be raised to produce a given number. So what does this actually look like? Well, if we were to write it out as a sort of generic function, we'd have something that looks a little bit like x is equal to log a b, where a is our base and b is could be any kind of constant number, and x will be our answer. So another definition you might think of is the logarithm in base a of b is the power that a must be raised to in order to obtain b. So we could think of sort of logarithms sort of as an inverse of an exponential function, because we can rewrite this as a to the power of x is going to be equal to b. So what's this going to look like with numbers? Well, let's go through and do an example. So if we have log in base, let's pick 3, and our number is going to be 81, is equal to 4. So if you were to punch log 3, 81 into a calculator, you'd come up with the answer as being 4. Now, I don't think that the graphics calculators will let you change the base, because it doesn't normally have a spot where we can put a in. So what calculators generally operate in is what we call base 10, and that's when, if we see log 81 or like that, it's actually operating in base 10. If we don't specify this number here, or a, it's operating in base 10. So what that means is that would have 10 to the power of something is going to equal 81. So whatever that number is, not 100% sure, but we could go through and work it out. So let's go through and just see what would this look like as an exponential function. Well, we'd have, and let's just grab out the bits of information we've been given and plug them into an exponential function here. So we can see that we're going to have a, which in this case, log a is going to be equal to 3. So we're going to have 3 to the power of x, which in this case is 4, is going to be equal to 81. Now, how do we know that 3 to the power of 4 is equal to 81? Well, let's go through and do our 3 powers. So we're going to have 3 to the power of 1 is just 3. 3 times 3, or 3 squared, is 9. 3 cubed, 3 times 3 times 3, is 27. Now, if we times 27 by 3, think about it, 20 times 3 is 60, 3 sevens are 21, 21 plus 60 is going to be 81. So we've got 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, and 3 to the power of 4. And that gives us 81. What if we want to go the other way, where we're given an exponential function and we want to write the logarithmic statement for it? Well, let's pick something like 2 to the power of a third is equal to 3 root 2, so cube root 2. Well, again, let's take our values and plug them into, so we've got our values here, let's plug them into this here. Well, in this case, we're going to have 1/3. It's going to be equal to log a, in this case, is 2, so we're on base 2, of b, which is the cube root of 2. It's that simple. So if we could put log 2 cube root 2 into our calculator, we'd come out with 1/3. What if we want to add or subtract logs or have a constant term out the front here? Well, these are where our laws of logarithms come in. So what we're going to do is define some of these laws. So we're going to use this basic form here and come up with some laws. It's worth noting that before we even get started that a, which will be our base, has to be greater than 0 and a cannot equal 1. Why can't it equal 1? Well, we'll just have 1 to the power of any number, which is just 1. So it's much like our exponential functions, where anything to the power, or 1 to the power of anything is just 1. Alright, so let's draw out some rules, and then we're going to go through some examples. So if we've got log a, m, where m's a number, plus log a, n, what this is going to be equal to is the log of a m times n. What if it's worth noting that we can only add the logs together if they're the same base, because the base has to be common. What if we decide to subtract? It's log a m, I'm going to keep using m and n, log a n. Well, if we've got plus here, we're doing the opposite here, it makes sense that this here is going to be the opposite. So what is the opposite of multiply? Well, let's divide. So we're going to go m divided by n. Now, it's always going to be the first one divided by the second one, because m divided by n is not equal to n divided by m. And the third rule that we're going to look at is going to be m log a, and I'm just going to use b. What this is actually going to be equal to is log a b to the power of m. And it's worth noting that there are some constraints for these, where for both these two, m and n have to be greater than 0, and here b also has to be greater than 0. Let's look at an example of this. What if I have 2 log 5 plus 2? Well, let's have a look at it. So we're going to have the logarithm of 5 to the power of 2. We're going to add to it the log of 10 to the power of 2. Now, it's worth noting we are in base 10 here because we don't have any base specified. So, we're going to have the log of 25 plus 10 to the power of 2 is 100, so the log of 100. What this is going to be, we're using our first rule here, so 25 times 100 is just going to give us the log of 2,500. And that's our answer. We could plug that into a calculator and see what the number comes out, and in fact, if I do that right now, we're going to end up with 3.397940009, and that's what my calculator will show. I'm sure it would keep going on for a while. So that's the basics of logarithms. So they do get a little bit more extravagant in the questions in the book. However, it's just a matter of breaking it down and seeing what we can find. So if you've got any questions, just ask, and as always, thank you for watching.